How does science allow us to represent the future climate? The scientific consensus is clear. Our climate is changing. That's why it is essential to be able to simulate it to help us adapt and plan a resilient future for all. Let's see how it works. Since you can't put the Earth in a lab, scientists use climate models to simulate the climate. They use complex software that dynamically represents physical processes and their interactions in the Earth's atmosphere, ocean, ice, and surface. These processes are represented by mathematical equations based on the laws of physics. They calculate variables such as temperature, humidity, precipitation, and barometric pressure. These processes include large-scale phenomena such as jet streams and complex small-scale processes like the microphysics of water droplets in clouds. There are several types of climate models, including global models, which simulate the global climate, and regional models, which focus on the climate of a specific area. Regional models simulate the climate over a smaller region, but with a more detailed spatial representation, which is needed for certain phenomena like freezing rain. Although climate models are not perfect, they have been successfully compared with observations and evaluated for decades. They make it possible to project changes in the climate system in accordance with societal behaviors and our greenhouse gas emissions. The increase in the atmospheric concentration of greenhouse gases is the main cause of global warming. They absorb the energy emitted by the Earth and return some of it to the surface, which has the effect of warming the atmosphere. Using the computing power of supercomputers, climate models translate how a change in the concentration of greenhouse gases will affect all components of the climate system, such as temperature, precipitation, and sea levels. Nearly 50 organizations around the world are developing climate models, each with its own strengths and weaknesses. For example, some models are better at simulating extreme precipitation over certain regions, but overestimating past warming. Others are excellent at representing sea ice cover, but may be less adequate for snow cover on the ground. That's why scientists always use multiple models to get a more reliable description of the climate. Despite their differences, the findings of all the models are clear and unequivocal. The observed increase in temperatures is due to greenhouse gas emissions from human activities. Climate models therefore enable us to see how our current actions will affect the evolution of the climate system. By making different assumptions about the socio-economic development of our societies, we can propose a range of potential scenarios. These are then linked to future greenhouse gas emissions and other climate-relevant parameters, such as land use. In the years to come, will our societies continue to emit significant amounts of greenhouse gases while maintaining high growth? Or will we succeed in transforming our economy and our lifestyles? The answer to these questions is in our hands. It depends on our current choices, which will be decisive for our future and for the next generations. To see how these different emission scenarios could affect the climate in Quebec's regions by the year 2100, check out the Ouranos climate platforms.